Guys, welcome back to my YouTube channel. So 7 years ago, I got into embedded system, and sincerely, it's been annoying, frustrating, challenging, time consuming, money consuming. However, it's really a very, very interesting field, and I think that um, for someone who is really interested in tech, for someone who is interested in how most things work, I think embedded system is that field that they should get into. So in this video, I want to talk about embedded system, how to get started with embedded system, and why I love embedded system so much. So without further ado, let's get into the business of today. So let's start with what embedded system is. Now, in order for me to efficiently explain what embedded system is, I want to start with something that we are all familiar with, right? Which are your desktop, your laptop, and your smartphone. Now, these three devices that I've mentioned are referred to as general purpose computer systems. General purpose computer system. Now, system because they are made up of software and hardware. Computers because they are their ability to compute data, and then general purpose because they are not designed for a specific purpose. Now, originally we all know that the phone was designed to make calls, right? But nowadays smartphones do more than just making calls, so they are also referred to as general purpose computer system. Now, your laptop, your desktop, and your smartphone can perform a lot of functions, right? And truthfully, the functions, or should I say the limits of these devices, are actually very dependent on the applications you have installed, right? So it means that if you want to do something related to music, all you need to do is just go to the App Store and download the music application. If you want to do something related to photography, go to the App Store and download a photography application, right? So the limits of these devices are based on the software you have installed. On the other hand, we have what we call an embedded system or embedded systems. Now, embedded systems are also computer systems. However, they are designed for a specific purpose, or they are designed for a specific function or functions. And it means that unlike a desktop, an embedded system can only do what it is created to do. And the truth is that embedded systems are everywhere. They are literally everywhere. Your computer mouse is an example of an embedded system. It is designed for one purpose, which is to control the pointer or your cursor on your system. Now, you also have things like your remote control. You have things like your smartwatch. You have things like your smart bulb or your smart lights. You have things like your microwave that has an embedded system inside. Now, in some cars, you have like a digital dashboard, and the digital dashboard itself is an embedded system because it has its own complete computing peripherals that is able to perform that task that it's designed for, which is to display things like your speed, your fuel gauge, and other things like that, right? We also have microwave, the timer on your microwave is an embedded system. You also have your smart door lock that allows you to use your fingerprint to unlock and lock your door. You can see that system is designed for a very specific purpose, which is to lock and unlock your door, right? Now, in most cases, as a matter of fact, embedded system contains the same basic things that the general purpose computer system contains, which is your memory, your processor, and some kind of inputs and outputs peripherals. So now the question is, why do we need embedded systems? All right, since we have general computers, general purpose computer that can perform most of what these embedded systems are designed to perform, why do we need embedded systems, right? Now, embedded systems, number one advantage is that they are cheap. Why do I have to buy $1,000 computer just to perform arithmetic calculations when I can get a $5 to $10 calculator that can do the same exact thing, right? Not everybody can afford a computer system. Not everybody needs to type. Not everybody needs to browse the internet. All they just need to do is to perform simple calculations in their supermarket or in their store. So why go for a computer system where you can get an embedded system that can do the same exact thing for you? Now, aside from that, embedded systems are actually very, very, very efficient at what they are designed for, right? A calculator is more efficient for calculating than a smartphone or a computer system, right? Now, take for instance a digital camera. Is an example of embedded system that is designed for taking pictures. And with digital camera, you can get very, very nice pictures on them, right? Now, you can also take pictures with your smartphone or with your laptop or with your desktop, but you can't compare the quality of those pictures to the quality that you get on a digital camera, right? So it means that a digital camera, when it comes to the area of photography, is going to perform much more efficiently, right, than a general computer system that is designed general purpose computer system that is designed for other things, right? So in this case, embedded systems are usually more efficient for what they are designed to, because the hardware that makes up the embedded system, the software or the firmware that makes up the embedded system is designed for that specific purpose. So it's more efficient in that specific domain. And also, embedded systems are much more portable. I can easily put a calculator into my wallet or into my pockets, right? But I can't easily put a laptop or a desktop into my pockets. And then finally, embedded systems are low powered, meaning they consume very little amount of energy. You could power an embedded system from a 3.3 volt battery with less than 1 milliamps, right, of current. However, the same thing does not apply to your desktop, your laptop, even though your phone also uses very low amounts of voltage, but at the same time the power efficiency or the power consumption is still much more than most embedded systems. There's some embedded system that actually lasts long for up to 5-10 years without actually charging them. Yes, some embedded systems like that, because they are very, very low powered, right, and they are designed to actually work with low power. So there are two major types of embedded system. Now, the first category is standalone embedded system, right? These are embedded systems that are designed to work on their own, right? They don't rely on any other system. So for instance, you have your wristwatch. It is designed to just tell you what the time is, and it does its job perfectly well without relying or communicating to other system. Now, we also have the second category, which are embedded systems that are embedded into a larger system. A very good example of this is your hard disk drive in your desktop computer or your laptop computer. So you see that hard disk drive is actually an embedded system. Within the hard disk drive, you actually have a microcontroller that coordinates the flow of data in and out of the hard disk drive. So itself, the hard disk drive is an embedded system that is embedded into a larger system, which is the system unit. Now, when I say embedded into a larger system, it doesn't necessarily mean physically embedded, right? It could also be embedded into a system of networked devices. So for instance, in home automation, we have several embedded systems like your smart plug, your smart door lock, your smart fan, your smart lights. All these things are all embedded systems, but they all are connected to like a central hub that coordinates the activity, right? So this is also an example of how embedded system can be in a much more larger system, right? Communicating either wirelessly or wired. So those are the two categories of embedded systems: the standalone and embedded systems that are embedded into a larger system, which could be a physical kind of connection or a networked kind of connection. So let's talk about the hardware side and the software side of embedded systems, right? And how to get started. Now, on the hardware side of embedded system, right? Just like a computer system, an embedded system has a processor and some kind of memory and some kind of input and output interface. However, in most cases, these things are usually very, very, very low spec, right? And in most cases, you can have all these things I just mentioned inside a single chip, right? And when you have something like that, it is referred to as a microcontroller. So in embedded system, one thing that is commonly used in most embedded systems is what we call a microcontroller. A microcontroller is simply an IC or a chip that has a processor, some kind of memory, and some kind of input output peripherals and other kind of peripherals like a ADC and SPI, I2C peripherals embedded into a single chip, right? So if you need to create an embedded system, let's say you want to create a smart door lock, all you need to do is just get this microcontroller, attach some kind of electromagnetic lock to it, and then write a firmware for it, right? And microcontrollers can be very, very, very small, right? They are usually very, very small. So this is an example of a microcontroller, and this one is called the STM32, and you can see how small it is. As a matter of fact, this whole thing is actually not the microcontroller. The microcontroller on this thing is actually this black piece of IC that you can see here. Now that is very, 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 very tiny. However, as small as it is, inside this IC you have a processor, a ARM processor to be more specific. You have secondary and primary memory inside this thing. That is, you have like RAM and a flash memory inside it, and you also have some other peripherals like analog to digital converter right inside this chip, right? Now the reason it is possible to combine all these things and then jam pack all these things into an IC that is this small is because all these things I mentioned are very, very, very low spec, right? So unlike your laptop where you can get up to like 32 gigabytes of RAM, in a microcontroller you most likely get less than 1 megabytes RAM. Sometimes you get 2 kilobytes, sometimes you get 1 kilobyte of RAM, right? And for the flash memory in a microcontroller also, you get very, very few megabytes or even kilobytes. So that's the reason why it is possible to, like, you know, have all these things inside a very tiny piece of IC like this. I have other types of microcontroller here. There is this one called the Arduino Zero, which is also a development board that has the actual microcontroller on it right here. In most cases, when you want to work with microcontrollers, you have to get things like this because it makes it easier for you to work with the microcontrollers. I also have this one, which is called the Raspberry Pi Pico. This was released recently, and it's also a microcontroller. In some cases, you need things like Wi-Fi or Bluetooth in your embedded system projects, and a microcontroller would not give you those features. Now, in cases like that, you want to go for what we refer to as what we call a system on chip. Now, an example of a system on chip is this ESP 8266 I have here. So you can see that this is much more larger than the MCU on this circuit board here, right? And this is because this has much more memory, a much more powerful processor, and also it has a Bluetooth peripheral. It also has Wi-Fi inbuilt all inside this system on chip that you see here. And the third component is what we refer to as a system on module. So sometimes you need extra peripherals like a GPU and some other complex peripherals, right? And you can't ordinarily fit all this into a chip, right? So what is done in cases like that is that you have what we call a system on module, or SOM, right? So a module is basically a circuit board, a PCB that can be inserted into a larger PCB. A very popular example of a system on module is what we call the Raspberry Pi Compute Module. So the Raspberry Pi Compute Module is a full system that has been designed in a very small form factor that is meant to be inserted into a larger PCB to perform some kind of complex operations. As a matter of fact, the Raspberry Pi CM4 or Compute Module 4 is capable of running an operating system, which we'll get back to shortly when we talk about the software side of embedded systems. Now, finally, we have what we call a single board computer. Now, just as the name implies, a single board computer, this is an example of a single board computer, and this is called the Raspberry Pi 3. So a single board computer is basically a full-fledged computer that has been strung down to fit a single circuit board. Now, unlike your desktop computer, if you open up a desktop computer, if you open up your system units, you can find a lot of other circuits inside of it. You find your motherboard, but aside from your motherboard, you find other things like your power supply. Inside your power supply, you have some other circuit board inside, right? So the system unit is not made up of a single board, right? However, a single board computer is a computer system that fits into a single circuit board like this. So in this circuit board, you have your processor, you have your RAM, you have your memory, you have your USB ports if you want to plug in your keyboard and mouse, or you want to plug in an Ethernet cable here. You also have your HDMI ports. Everything has been fitted into a single board, right? And this can run Android, this can run Linux, and this can even run Windows, right? And this is much larger than a microcontroller or a system on chip because it has much more peripherals and much more features, right? So this is mostly the components you use in embedded system projects: your microcontroller, your system on chip, your system on module, or a single board computer. So that's for the hardware aspect of embedded systems. So let's talk about the software side of embedded system. So there are three basic ways to go about writing firmware for embedded systems, right? Now, you've gotten your microcontroller, you've gotten your SoC, or you've gotten your single board computer. You need to write the software that controls the activity of the embedded device, right? So now the first option is for you to write a program with some kind of software and then upload the program directly into your microcontroller or system on chip, right? Now this program are usually written in assembly or in C or C++. And once you're done writing this program, you compile them and send them to your microcontroller using a specific kind of software. Now this firmware you write is designed to interact with the hardware and peripherals of the microcontroller or in the microcontroller, and then they're usually very, very low level, right? Meaning they're actually more complex to write when you're writing software for, let's say, a smartphone or for a Windows operating system which runs on a general purpose computer, right? So that's the first option. Now the second option is to use what we call real-time operating systems for your microcontrollers or system on chips. And this is basically a low-level operating system that is designed for microcontrollers or system on chips that allows you to do things like multi-processing and multi-threading on microcontrollers. So the last option, which is like my favorite but also the expensive option because it requires a much more powerful components like a system on chip or a system on module or a single board computer, and this option is what we call embedded Linux. So Linux is actually an operating system that is designed for a general purpose computer, but there's a version of Linux, or you can actually make Linux so simplified that it can be run on embedded system, and this is referred to as embedded Linux. So using embedded Linux in embedded system project is having a full-fledged operating system on your embedded device and then writing program on top of that. So in this case, you can write program with Python, C++, or any other language of your choice, since you run a full-fledged operating system on your embedded system. Alright, enough of the technical explanation. Now the question is, how do you get started with embedded system? Now I know with all I've said so far, it looks like a very, very complex field, and the truth is that sometimes it could be very, very difficult, right? But at the same time, there are actually very, very easy way to get into embedded system. Now I'm going to recommend a platform called Arduino. So just go online and Google Arduino, or just type Arduino for beginners on YouTube. You're going to see a lot of tutorials, right? So Arduino is actually a platform that allows the use of microcontroller, and also that allows a easier approach to programming firmwares for microcontrollers, right? Another very important thing that you need to know how to do is you need to know how to program, and I would say go for C++/C, right? In most cases, C++ and C is enough for you to get started, is enough for you to even become a professional in embedded system, right? If you want to take things further and you want to use things like embedded Linux, then you can learn Python for embedded system, or you can actually use something called MicroPython, which is compatible with things like ESP8266 or ESP32 system on chips. So when you're familiar with computer programming in C++/C, I think the next thing is for you to understand electronics. Simple basic electronics, things like capacitors, things like resistance, voltage, and how all these things work together, right? And then finally, you also need to understand the basic of computer systems generally, things like memory, your RAM, your flash memory, your processor, all those basic things that applies to both general computing system and embedded systems. You need to understand those things. It gives you a better understanding of what you're doing, because and also makes it easier for you to debug and troubleshoot your firmware. So guys, those are the three key things I think that would kickstart your journey in embedded system. Learn C/C++, know the basic of electronics, and also understand how computers work generally. Alright, thank you guys for watching today's video, and I hope that I just inspired somebody to get into embedded system. So personally, I love embedded systems because it is just everywhere, right? Embedded system are things that we interact with every day, right? So if you're an embedded system engineer and you're actually very good in embedded system, you would forever remain valuable and relevant in the world, right? Generally, because there's always a need for embedded system experts, right? So embedded system is a very great field, right? It could be frustrating, it could be challenging, and sometimes it becomes very complex. But at the end of the day, if you can really get into it and get committed to it, you're going to figure it out, and you're going to begin to make interesting projects in embedded systems, right? So guys, if you've not subscribed to my channel, this is the perfect time to do so, and also like and also share this video. Thank you very much, and I'll see you in the next video. So there are two categories of embedded system, right? Or embedded system So there are two categories of embedded system, or should I say there are two major categories of embedded systems. The first category are standalone embedded system. Is. God help me, Jesus. So there are two main categories of embedded system, and the first category is